Professor Boron. You look a little different.
Hey man, what's going on?
New shades?
Yeah, you got yours?
They're right here. Yeah. What happened with the whole getup that you had to suit and stuff?
I just decided to let that go. Nothing really matters.
Well, that costs a lot of money. You too as well.
I know, but whatever.
Not alcohol?
No? No?
Okay, well, I was gonna say. Oh.
It's just water.
Okay.
Right?
Well, this is my lunch as well, so I'm just...
You know, I haven't had something to eat in 2 days.
Oh, well, why is that? Tell me.
I don't know.
Okay. Also, your tie, you definitely changed ways. Like, how?
Oh, I didn't notice that. Sorry.
You okay?
Yeah, I'm fine. Oh,
You getting ready for this?
yeah, I'm totally ready.
Hey man, hey. Are you sure you can do this today? You're way out of it.
Hey man, this is easy. I can do this in my sleep. You have no worries. I can do this. It's
Well,
fine.
You sure?
Yeah.
Okay,
Don't patronize me. I can do it.
Our lesson is on the periodic table.
Yeah.
it's not too hard.
Yeah.
I mean, just
I studied that
5
when I was-
minutes. You got this.
Yeah.
right?
Whatever. I can do it. It's fine.
All right. Well, let's get to it.
I'm still convinced that's alcohol.
Hey,
But
you know
let's
what?
continue.
Shut it.
You might have a problem, but yeah.
It is a fascinating journey, this path of knowledge, and the vehicle we ride is a science called chemistry. Here we go!
I'm so glad I don't have a headache now.
Yeah.
Action. Go. Action. Go.
What?
Boron. We're starting.
Oh. I guess we should start.
Welcome back to Chemistry for Kids. And today we're going to learn more about the periodic table. So, the periodic table is an interesting concept. When you have someone like Mendeleev, correct? Mendeleev?
Yeah.
Mendeleev, he's the one that created, he's the one that said that the periodic table should be structured in the way that the atomic number should be ordered increasingly. So when you have something like hydrogen, the hydrogen has 1 proton, helium has 2, and it goes from left to right all the way down to the lanthanide and actinide series. But we'll get to that. Then more groups of individuals said that how about we move the lanthanide and actinide series down so that it fits more of the transition levels it lines up with. So that's what we see here. The D, this is the transition metals right here, the D portion. The metals, well, they're all metals. This is transition metals. This is more metals of the other kind.
Hey, do you mind? I can talk about this if you want.
Yeah, sure. Go ahead.
Yeah. I don't know. What did you say, Alan?
I said these are transition metals.
Sure. Yeah. So, okay, this is pretty easy. You know, you got metals. Metals here. It says metals. I like metals, but just careful. You know, okay. So metal is this division here. Okay, anything that lies on that division, it's a metal, right? That's just how it is.
So aluminum, right? Aluminum is the only exception.
Yes.
All right.
Yeah. Yeah. Actually, you're right.
Everything else is.
About that.
Everything else is a metalloid, such as
Yeah.
electroplating. Anyways,
And then something like right side, left, right side. Yeah. Your phosphorus, for example, that's a non-metal, but you know things like that, oxygen, like gases. You know, anything with their gases. That's you know the metals. No, they're gases for the most part. But everything over here, past this, it's a metal, and then anything on that line is a metalloid. So yeah. And usually they're grouped up in this way, right? Because it's talking about the different families, and you know it's depending on the properties. he'll get into that later. There's also different periods of rows that exist there.
It's like a total of 7 periods. 7 periods and 18 groups. We'll get to that later.
Yeah, you're right actually. Good job. Yeah. So all of the like the SDPF that stuff. That's based on like electron orbitals, but you know, we'll get into that later. But for that, and you know, reference, it is good to know those.
Okay, I guess we could talk about the properties now.
Yeah, sure.
So here's some of the families that, once you go down the column, they're all related in some way. So group 1, for example, and let me specify, you can call them however you want. The group 1 can be referred to as 1 or 1A. That 1A portion is in relation to the valence electrons that the elements have, which means the outermost electrons. Not the entire electron spectrum, but the ones on the outer ring, that whatever it is. So according to the group 1 is called alkali metals, and alkali metals are extremely reactive, especially in water. And they're also considered super soft, meaning that you can cut something like sodium. You can cut sodium with a butter knife, easily like that. And with anything else as well, lithium and potassium, anything like that. Group 2 metals, they're the alkaline earth metals. They're basically alkali metals, but to a lesser extent. So if you compare something to calcium to potassium, then the calcium is going to react a little bit less than the potassium. Then this whole portion right here is called the transition metals. And transition metals are a little bit different than these other metals over here, considering that the transition metals have colored solutions. There's various colors for these metals. You have copper.
Copper's blue.
Copper's blue.
I like my tie.
That's cool. So copper's blue. There's many other forms as well.
Yeah.
Cobalt, chromium, all those things have different sorts of colors. Then, as we move on, we have the halogens. That's the row of the gases. Pretty toxic gases as well. We have the alcohols. Sorry, it's not alcohol.
It's water. H2O. Remember? H2O.
Mm-hmm.
It's good for you.
Okay. Anyways, the halogens, they're gases and they're diatomic, meaning that if you write gases alone in their neutral state, they end up as this. You have to include the 2 at the bottom and the way to recognize this is that there's only 7 elements that can have a diatomic form. And so what you want to do is you want to start at hydrogen and then go to nitrogen and then make a 7. So basically the 7 elements is hydrogen, nitrogen, oxygen, chlorine, chlorine, bromium, and iodine.
Sorry. I think some of that
What?
sugar got into my throat. Continue.
Is this right?
Just,
Yeah,
yeah.
this is right.
Yeah, you're
So
right. You're good.
These are the 7 elements that can have a diatomic form. Usually you do not to you start at 7 and you make a 7, but just follow this. Memorize this if you can, and yeah. And this is only when it's in its neutral state. Something like that. So now we're moving on to the noble gases, which they basically don't want to react with anything. They already have the set valence electrons. If you look at here, 8A, meaning that they have 8. That's the perfect number. Number 8 is what the elements want to have.
Why?
Why?
Why would they want that?
Why would they want 8?
Why would anyone want 8? Stupid number.
It's just,
Are you telling me because some stupid rule says, oh, 8 because it works in octaves? That's dumb. Why?
well, that's it does work. Yeah.
Yeah, I don't care. Stupid.
Well,
This is all stupid.
okay. Do you want to explain it then?
No.
Hold on, guys. Come on. Listen up. Boron, look, take a little break. Just take a 5-minute break. Come back later.
Fine.
Let's set the board up for the next section.
Did I explain that?
Master Chemist. Professor Boron, he's not feeling too well, so we're just having him sit out this episode, the rest of the episode.
What happened then?
He's just, not feeling well. I don't know. He's, whatever.
I could see that.
Yeah,
I could
just,
see that.
so yeah, you got this one. Just finish it up. Yeah.
Okay, that's cool. Do you want me to start now?
Yeah, whenever you're ready.
Okay, so sorry for that intermission, folks, but I'll be on the spotlight for this one today. So we're going to talk more about the periodic table, primarily like the atomic trends or the periodic trends that happen within the periodic table. So if we go over here, there's like 5 main things that you should study for or what you should know: atomic radius, ionization energy, ion atomic radius, reactivity, and electronegativity. So the first thing, atomic radius is the size of that element. So if we look at something like hydrogen here and helium over here, then hydrogen is going to be a little bit bigger than helium. So, but that's because what happens in the atomic radius is that there are less protons that are being applied to the hydrogen rather than the helium, meaning that since there's less protons, the electrons are not going to be as attractive to the protons as it will be to helium, meaning that it's going to increase in size. So, and there's also a bit of electron shielding as well. So if you have something like this electron right here is pushing these 2 electrons back, further increasing the atomic radius. So now that we have that out of the way, we also have something called ionization energy. Ionization energy is the energy to remove an electron. So we can see here as you go up the periodic table and to the right of the periodic table, then that has the most ionization energy. So it's looking like helium that has the greatest ionization energy. And I forgot to mention the atomic radius. Francium down here at the bottom also has the greatest atomic mass, but continuing on. The ionization energy, the energy to remove an electron. So basically, it's opposite of the atomic radius. The ionization energy is you have more protons when you're coming back, when you're coming over here, like moving to the right of the periodic table. And since you're having more protons, the electrons are being attached to more of those protons, meaning that it's going to be smaller in atomic radius, which is why you see that the trend downwards here and left here, but up here it's up and to the right. So helium is very closely bonded with the electrons and the protons, and that's why its radius is smaller. But since it's so close together, you have something called the Coulombic force of attraction, meaning that since it's so bonded together, the helium is going to be even harder to pull the electrons and the protons from, which is why we measure that in the energy levels that it has. Right now, helium has 1 energy level. So if you have something like, let's say, argon has 3 energy levels. And I'm getting these energy levels because of the period that they're in. So argon has 3. So you have something like argon, and the valence electrons that it has are 1, 2, let's see. So we got 8 valence electrons. These other electrons that are in here, that are surrounding the argon, these electrons here are pushing these back. But since there's less protons in the argon section, for argon the element, then these electrons are not being pushed back as often as, let's say, something as hydrogen. So you have something like that. You have something so closely bonded together, it's going to be difficult to remove those electrons from those energy levels. Next up, we have the ion atomic radius. Okay, so basically, previously, in the previous portion of this video, we talked about how these things are called ions, and these ions you can remove and add an electron to them. So if you remove it, then this right here, copper, is gonna it's gonna be more positive because you're removing a negatively charged particle. And then Cl, if you add an electron, you're adding a negatively charged particle, which is gonna be Cl negative. And so when we talk about radius here, we're talking about if we compare these two, this one would have the largest radius, and the Cl negative would also have the largest radius. How I like to think about this is, if you remove an electron, then you're also removing parts of its mass, which means that this is going to be ultimately bigger than this one, and that if you're adding an electron, this is going to be bigger than the one without that extra electron.
Hey! Electrons don't have mass. What are you talking about?
I'm sorry, what?
You're wrong. They don't have mass. Dumbo.
Okay, well, okay. Boron, come on, I'm gonna have to. Let's go out.
Hey,
come on,
hey,
Boron,
no,
come on, come on,
no.
come with me.
It's unfair.
Look, this.
You can't do anything
Come on,
about it.
this.
Okay, continuing on. Okay, so it doesn't have mass.
Actually, I mean, it's not about mass. It's about the Coulombic force of attraction.
Force.
Yes.
So if you have less of electrons, right, then those less electrons are not going to be. You have one less, meaning that they're not going to be as bonded to the protons as much as you would want. Meaning that the area is going to increase, the radius is going to increase, because more electrons are going to be out in some sort of theoretical field, which means it's going to be much larger. And the same thing goes for this one. If you add an extra electron, those protons and electrons are going to come together, and they're going to be closely together. They're going to be compact, and that's what makes the radius just a little bit smaller, but a little bit bigger as well. I mean, this is going to be small, this is going to be big. So for something like reactivity now, when we talk about reactivity, we're talking about there's like the non-metals reverse, and the metals. When we talk about this, we talk about sodium, right? Correct? We talk about sodium, something like this. As we mentioned before, the alkaline earth metals, or the alkaline metals, the alkaline metals, they're extremely reactive with water. They're extremely reactive at all. So the alkaline metals here is something that's going to be extremely reactive in water. Let's say, and then we have sodium, and then we have lithium over here. Lithium is going to be less reactive than the sodium, because the reactivity goes down in this periodic table. But the opposite can be said for the nonmetals. So if we have something like fluorine and something like calcium, then this is gonna So the fluorine is going to be much more reactive than the chlorine, and that's the science behind that. For some reason, I think it's their properties that makes it more reactive than not. So next, and then lastly, we're on electronegativity. It's basically the same trend as ionization energy. So yeah, make sure you don't forget that.
Master Chemist,
Yeah, what?
what's going on?
I don't know. I blanked out.
What? Okay, bye.
Welcome back to the Chemistry Corner, and today we're going to go over some more user-submitted questions. So let's open the archives. Stacked as always. And the first question is from MidP14. And he says, as a biology student, I am so glad I didn't take chemistry. So what's the 14 supposed to mean? You're great in bio? Anyways, the second question is from Marmaduke_Ironside. What's your favorite element? Definitely sodium. It is a group 1 metal after all, so group 1 metals are obviously superior. And sodium is it's pretty versatile. So yeah, I like it. And the third question is from real Donald Trump. Okay, and he says, so very, very sad. This is why we need to privatize the education system. Thank you, Donald Trump. Okay, thank you. I guess. That's Chemist. Signing out. Hi, welcome back. This is the interview portion of Chemistry for Kids, and I have with me here, what's your name?
Mr. Dumity.
Mr. Dooney. And what's your profession?
I am a engineer come math teacher.
Oh, and what's your experience in chemistry?
Ooh, chemistry. Chemistry is a long time ago for me, but it has helped me immensely in my studies of math.
That's very good to hear. And can you say the same for biology?
Biology has a lot of math in it too, sure. And remember, first comes chemistry and then becomes biology.
Absolutely, I agree with you there. Last question. So, in terms of like your knowledge in chemistry, how would that be related back to how you like profess as a teacher?
How I profess as a teacher.
Yeah, how you teach.
Well,
Chemistry.
I mean, chemistry is sort of a very exact science, and it's very step by step. And my learning about chemistry, although I've forgotten much about it over the 40 years since I've had it, some of the basic concepts I keep using over and over again.
All right. Thank you so much, Mr. Doomity, everybody. Thank you.
You're welcome.
Professor Boron! Professor Boron! We're looking all over for you.
Why?
Well, after what I heard about what happened, you got kicked out, and producers kind of like almost let you go. I saw a little bit of alcohol problem. A little bit of an alcohol problem, right? And I was just wondering how you're doing. I thought you left. But you left the.
I don't know. I'm alright, I guess.
You okay?
Sort of.
Where's your car?
Repossessed.
There's a lot of that stuff here. Listen, life is gonna hit you hard sometimes.
I mean, it already is hit me, and I'm kind of bruised right now.
It's gonna hit you with the left, and it's gonna hit you in the right, and then it's gonna go for the uppercut, the final blow.
Yeah.
But hey, listen,
What?
you gotta persevere.
Persevere?
I didn't get these goggles through just light work. I got these through hard work. Right? And one day you might have these goggles.
You hard work? Really? Okay.
But
Sorry. Sorry about that. I didn't
That's good.
insult you.
Yeah. I'm trying to give you an inspiring quote for me. Anyways, I'm sorry about your part. But, I think you're right. I think you're really wrong.
Thanks, man. I actually did that.
Alright. Let's go then.
Alright. Cool. Thanks a lot.